All right, first day of exponential function. So this top part here, this is just reviewing rules of exponents that you have already been through at some point in your mathematical career. So if you are multiplying two things, that means those exponents ended up getting added together. Division is the opposite, where you subtract them. Power to a power, you multiply. Power of a product, both parts, or all parts, I should say, end up getting the exponent. Same thing if you're dividing with a quotient. Everything gets that exponent. Anything to the 0 is a 1. And then negative exponents, I like to think of it as repeated division. Positive exponents are repeated multiplication, and negative exponents are repeated division. So let's go through some examples here. So as I was saying, here we have the power of a product. So you're going to multiply that exponent times both of those. That gives me x to the 8, y to the negative 4. But we can never actually leave negative exponents. So that becomes x to the 8th over y to the 4th. That y to the 4th moves to the bottom because, again, negative exponents are repeated division. Example 2, we got some division here. We've got this like base of 3. So I subtract those exponents. 9 minus 6 makes it 3 to the 3rd. 4, and then it's going to end up being to the first power because 3 minus 2 is a 1. So 3 to the 3rd ends up being 27. Times the 4 gives us 108 is our final answer there. Example 3, this is using our 0 exponent rule. However, the 0 exponent is only on the letter z. So 5x is going to stay as 5x, and that z turns into a 1. So it ends up being 5x times 1. So that's simply 5x. Over here, negative exponents need to move to the other part of the fraction in order to turn positive. So that gives me x y to the 3rd over 3 squared times 4. So always simplifying things down. 3 squared is 9 times 4 makes that a 36 in the denominator. Example 5 over here, multiplying, so we need to add these exponents. 2a plus 1a makes that x to the 3a. And then over here, you want to multiply that denominator first. 7. Numerator stays the way it is for now. We get 9, p to the 4th, k, n to the 7th. Order really doesn't matter. As long as you got them all in there, we're good to go. So the 6 and the 9, I can reduce those both by 3. So 6 divided by 3 gives me 2. 9 divided by 3 gives me 3. I'll go with my k next. 8 minus 1 makes that k to the 7th. 4 minus 7 makes that a negative 3, which means my n is in my denominator to be positive. And then 7 minus 4 makes that p to the 3rd in the numerator. So there's our final answer for that one. Going on to the back page, rules of exponents, just practicing a little bit more of a numerical basis because people tend to actually divide the bases when you're really not supposed to. So for this one again, power to a power, so I multiply those. My 2 doesn't change into an 8, which is what a lot of people tend to do because they see that 2 to the 3rd there. It stays as a 2. Then here, multiply my exponents again, so negative 7 times 4 gives me negative 28. Now I'm going to add my exponents there. That becomes a 17. 45 plus a negative 28 would give me 2 to the 17th, which then at that point you could use your calculator and simplify that down to figure out what 2 to the 17th is. I can't do that one in my head. So in my calculator, that ends up being 131,072. So next one again, power to a power, so that's 6 to the negative 6 over 6 to the negative 3 times 6. Using my division rules here, that would give me 6 to the negative 3, because negative 6 minus negative 3. And then times 6 to the first, so that's 6 to the negative 2, which is 1 over 6 squared, which would be 1 over 36. So, how can you use the fact that 25 squared equals 625 to show that 5 to the negative 4th equals 1 over 625? So again, these negative exponents means that it's a division. So this 625 is really to the negative 1 power there. And then I can rewrite this 5. That's, 5 squared. Well, let's go back a second. Rewrite this 25. That would be 5 squared. And then it's still squared, which if we use our power to a power rule is 5 to the 4th. Because it's negative, that means it's 1 over 5 to the 4th. So it ends up being the same thing. Because again, 25 can be rewritten as 5 squared. And then you still have this squared here, which ends up being 5 to the 4th when you use your power to a power rule. So use your exponents rules to simplify these ones. So again, we have two different bases. I got a base of 4 and I got a base of 2. So my 4, I'm going to change as 2 squared, and then it's still to the 25th. And then my denominator there, my power to a power, that would be 30. So it ends up being 2 to the 50th over 2 to the 30th, which is 2 to the 20th. So right now we're just going to practice simplifying those exponents down. This one's a little trickier. We got a 10, a 4, and a 5. So my 10, if I do my prime factorization, which if you remember, prime factorization means that you rewrite it as terms of just the prime numbers. 10 can be prime factorized down into 2 times 5. So that means it's 2 to the 8th times 5 to the 8th because of our power of a product rule. And again, 4 can be rewritten as 2 squared, so that's going to be 2 to the negative 10 when I multiply those exponents there. All over 5 to the 6th. 5 is already a prime factor, so you can't change that one at all either. So I'm cleaning this up, looking at my 2's. 8 plus a negative 10 makes that 2 to the negative 2. My division rule here, that gives me 5 to the 2nd, which is 5 squared over 2 to the positive 2, so 25 over 4. Ends up being our final answer for that one. And then our last part down here on this page, our exponent rules also apply to your scientific notation. So with these numbers, you could rewrite them into scientific notation. 1, 2, 3, 4. Remember, the first number has to be between 1 and 10. So that's why I need to put my decimal right here in between the 1 and the 3. This one would be 2 times 10, or 1, 2, 3, 4, 5, 6, 7, negative 7. So rewrite them as scientific notation. You're going to multiply the first number, so 1.3 times 2 would give me 2.6. And then same rules, add your exponents here, so 10 to the negative 3. And then that ends up being our final answer there. So 7, this would change into 4 times 10 to the 1, 2, negative 5. Over 2 times 10 to the 4, 5, 6, 7, negative 7. So 4 divided by 2 gives me 2. Negative 5 minus negative 7 makes that a positive 2. So 2 times 10 squared. And then our last one here, again, this would have to go to the 1.2 and to that. So 1.2 to the negative 6.
All students that are here for the OCC and Davis field trip, please report to the Hall of Fame to be bestowed. Once again, all students here for the OCC and Davis field trip, please report to the Hall of Fame to be bestowed. Thank you.
All right, so again, negative exponent goes to both of those. This would give me a negative 18, but when I raise that, gave me a 0.33, so I had to move my decimal over again, which is why I have a 17 there. So then, division 1, we get 8.25 times 10 to the 13. So again, when we subtract, we would get a 14. However, this number was a decimal, so we had to move that decimal back over again, which is why it turned into a 13. So that one is our final answer there. Last page for today, fractional exponents. We haven't really seen fractional exponents yet. But when you take the fraction part, the fraction exponent there, the top part of the fraction is your power, bottom part is your root, which is why I rewrote it in this manner here. So the root goes in front of the radical, power goes on the outside. So looking at our examples here, again, power over root. So this is a cube root of y and then squared. Now, you could also put the squared under the radical. It doesn't really matter where that part goes. But generally, I have found it's easier if you take the root first and then raise it to the exponent afterwards. So I always tend to put it on the outside. But our next one, a is just simply to the first power, but for b, it's the fourth root of b to the first power. And again, remember, we don't have to write those exponents of 1 there. For c, we've got 3 times the 7th root of mn to the 5th power. And then these ones we're going to go the other way, so we're going to write them with the fractional exponent. That becomes x over the 5/3, power over root. Remember, the root here is a 2. If there's no number written there, it's a 2. And then our power is a 1 there. And then this one would be 3 times 3 to the 1/4 power. Following our multiplication rules, an exponent of 1 plus 1/4 would be 5/4. So 3 to the 5/4 for that one. So these ones we're going to actually evaluate. So cube root of 27 squared cube root of 27 would be 3. So then 3 squared gives me 9. Here we got the cube root of 1,000 and then squared all over 5. Cube root of 1,000 is 10. 10 squared is 100. 100 divided by 5 gives me 20. Third one is negative, so that just means same thing happens, but it's going to be in the denominator this time. So it's 1 over the square root of 9 to the 3rd power. Square root of 9 is 3. 3 to the 3rd is 27, so it becomes 1 over 27. For given the function there, find the y-intercept. Y-intercept, remember, is when x is a 0, so we're going to plug in a 0 here. So that's negative 3, and then it's 8 to the 2/3. So that means it's the cube root of 8 squared. So the cube root of 8 is a 2. 2 squared gives us a 4. So negative 3 times 4. So the y-intercept would be at negative 12. Number 5, our last one there, they want us to plug in 8 over 27 for x. 8 over 27 to the negative 1/3. So again, the negative means that it's going to be a fraction, but it is already a fraction. So what happens is that fraction flips. So when you got that negative there and it's already a fraction, you just flip it. And then it's going to be the cube root of those to the 1st power. So the cube root of 27 is a 3, cube root of 8 is 2. So that ends up being 3/2.